Okay, let's talk a little bit about the physics of cutting tools and how they operate. So in the next section, when we look at how we design tools, we can understand why they're designed the way they are. For starters, let's go ahead and look at the speeds of the cutting tools themselves. I'll go ahead and grab a pin here. So let's just pretend this here is going to be our cutting tool. I'll go ahead and shade that in. And it's coming down on a flat surface here. This is supposed to be horizontal. Sorry for my bad drawing. Okay, so for starters, we have a rim speed, and that speed is the velocity of the cutting tool itself because of its rotation. So as it's moving around this way, like so, that will be the rim speed. I'll go ahead and choose a color here and draw this out, and we'll call that VR. This will be the tangent speed coming off as it's spinning. Secondly, we have a feed speed, and this is the speed of the tool as it's moving across the workpiece. So this would be basically the X and the Y speed as it's moving across cutting the piece. So I'll go ahead and grab another color for that, and that would be this direction here, and we'll call that VF for feed. Next, what we have is the true speed, and this is the speed of the resultant from the rim speed and the feed speed itself. So let's go ahead and choose another color and label that in, and that's basically going to be these two added, and they're going to be added kind of like vectors, if you remember. So we're going to kind of come across this way, come up, so the resultant will be something along the lines of here, VR. So these two speeds here affect the speed of the actual cutting tool itself. The rim speed will increase when the rotational speed increases, of course, and it will also increase when the spindle diameter of the tool increases as well. So a larger diameter tool will increase this speed overall. The feed speed will also just depend on the motor itself as it moves across the X and Y direction. Now let me go ahead and pan over to the side just a bit and find an empty space over here. Now let's talk a little bit about the angle that the tool penetrates the material that it's going to cut. So let me go ahead and grab another color here. Alright, that one should be good enough. So we have the tool as it comes down, kind of goes back a bit and goes up. It's going to be penetrating a small surface that's on the floor. Let me go ahead and change the color. And there are going to be three important angles here to look at. And as it's hitting this point here, this will be its contact point. These are the three angles that we're going to be looking at. This one here is going to be your alpha angle. Sorry if it's a poor alpha for some people. This is your beta, and this here will be your gamma. Now this angle here for alpha is known as your rake. This angle here for your beta is going to be your knife angle. The angle here for the gamma is going to be your relief. And here your beta is going to be determined by these two angles here. So your beta is going to equal 90 degrees minus your alpha and your gamma. So this angle here, your rake, which is also known as your alpha, this angle is very important for making sure you have a proper high quality cut. An optimal angle is largely determined by the material's hardness, of course. A larger rake angle also will result in a sharper cutting tool, but as it gets sharper, it will also be able to penetrate more easily, and that also makes the tool a little more fragile, because if it gets a lot more sharper, it's basically going to be thinner as a tool itself. On the other hand, if you make the angle smaller, then that reduces the ability of the tool to penetrate the material efficiently, but it also increases the strength of the cutting tool itself and reduces the wear on the tool. Now, as for the relief angle, it's important to have an angle here to make sure that the tool itself doesn't rub against the surface that you're trying to cut on. And when this angle is too small, it's going to generate excess friction, and the resulting heat is going to help wear down the tool. A relief angle that's too large, on the other hand, will lead to a fragile cutting tool itself. So as this angle gets larger, this beta here is going to get smaller, so it's going to become a lot thinner for the tool itself. And again, if it's a lot thinner, it might be easier to snap. So again, the knife angle itself, it's going to affect the rate of the wear in two different ways. First, a larger knife angle will result in a stronger cutting material and have less wear. Secondly, the larger knife angle is going to conduct heat better, and the distributing heat over more of the material and carrying it away from the cutting tool will help reduce the wear and increase the life of the tool. But a smaller angle for the knife angle will make the cutting tool a lot more sharper and able to penetrate better. So it's a balancing act between having the strength and the penetrability of the tool itself. And another thing to look at, let's kind of create a top-down view of this here. So if this is my cutting tool coming straight down, if we're looking from there, I'll call this the top. So this is the cutting portion here. So the cut is going to be this portion here, and this here will be the travel direction, which is this right here, travel. So it's coming this way and that's coming that way right there. So this angle here as it travels, as opposed to if it was normal, the tool would be slightly slanted a bit. Even though this is still the direction of travel, it's just kind of creating a little angle here. This is going to be called your oblique angle. So when the cutting tool is not perpendicular to the tool's direction of movement, that's going to be your oblique angle. Now these reduce the cutting stresses on the knife itself, and they also improve the tool life, and they reduce the edge chipping of the material and result in an overall higher quality of a cut. So you'll typically see these type of cuts with a oblique angle. Now let's go ahead and look at another picture really quick. If I pull this up, these are three different angles for the cutting tool here, and you can see we have an angle here, this angle here for the knife, and we have the relief. So depending on the angle for the rake will cause different chips. For example, this is just being displayed against a wood grain, for example. So if you want a larger angle here, we'll go ahead to be better for cutting across the grain, preferred for cutting with the grain if it's kind of moderate, and if it becomes very sharp, a small angle here, this is preferred for scraping. And again, this can be applied to various drills as well. As you can see, this would be the oblique angle that we were mentioning with the typical tool right here. So it applies to the same thing here. They also have a rake, a relief, and knife angle. So those three angles combined on here, they will have those angles on the very tip as it penetrates if you want this tool to plunge into a type of material, as well as on the sides of the material itself.